Okay, this is part 2 of the notes on section 2.7. So section 2.7, the inverse function property. So you want to write this down, the inverse function property. Let f be a one-to-one function with domain A and range B. The inverse function, f to the negative 1, satisfies the following cancellation properties. Okay, so f to the negative 1 of f of x is equal to x for all x in A, and f of negative 1 of x equals x for all x in B. What that means is when you compose the functions in both directions, so the inverse function of the original and the original of the inverse function, you need to get x for both of them when you simplify in order for it to be an inverse function. Okay, so let's look at an example. All right, so we want to verify that these two given functions are inverses of each other. All right, and in order to show their inverses, f of g of x must equal x and g of f of x must equal x. Okay, so we're going to show that both of these equal x. All right, so f of g of x. So f of x to the 1/3 means I take x to the 1/3 and raise it to the 3rd power. Power to a power means you multiply. So 1/3 times 3 is 1. So that's just regular old x. All right, so now let's check g of f of x. So g of f of x is x to the 3rd. So I want to take g and wherever x used to be, substitute x to the 3rd. Once again, power to a power, you multiply them, and we're left with x. Okay, so therefore, f and g are inverses of each other. All right, so I want you to try this one on your own in your notes. So you have two functions. I want you to show that they're inverses, meaning you need to show that this equals x and that this equals x.